So here I have logged into my DigitalOcean droplet, and now I will be showing you the code. We can get the code by typing the commands sudo nano. The name of my project file is boltproject.py. So this is the code which we have for our project, and here I wanted to show at first that what happens when our device is not plugged in properly. So let us just run this command. We can run it using the commands python 3 bolt project.py. So here you can see that it is clearly saying that my device is offline, and it is asking me to make sure that the IoT module has been properly plugged in.
Alright, so I will walk you through the circuit first. So as you can see, I have already plugged in my Bolt IoT Wi-Fi module and both the LEDs are already glowing, which means that it is connected to the cloud as well. Now here is the circuit, and this is a piezo buzzer, and it is connected via this white wire to the port 1 of the Bolt IoT Wi-Fi module. Up next, this is the red LED and that is the blue LED. Now this blue LED is connected to the port 2 of the Bolt IoT Wi-Fi module, and the red LED is connected via this purple wire to the port 3 of the Bolt IoT Wi-Fi module. This is the LM35 sensor which we will be using to sense the temperature. It is connected to the 5-volt port of the Bolt IoT Wi-Fi module at one end. The second pin is actually connected to the analog pin A0, analog port A0 of the Bolt IoT Wi-Fi module, and the third pin is connected via this white wire to a common ground terminal that we have created on the breadboard. So now we have our Bolt module plugged into our laptop, and we have our phone in hand, and this is the phone where all our SMS will be coming in. We are ready to execute the code while our IoT module has been plugged in. So now you can see that the reading of the sensor is being displayed on the screen, and no SMS has reached our cell phone yet. Now the second reading is also available on screen, and it will continue to do so after every 10 seconds.
So from the observations, we can clearly infer that the temperature of the sensor remains somewhere around 32 degrees Celsius unless it is affected by some external conditions. So if we want to test our next case, wherein we would want our sensor to respond to a scenario where the temperature sensed by it is greater than the maximum threshold that is set for the temperature variable. Now you can obviously try to do that by bringing a source of heat near your sensor and letting it detect that. However, for safety issues, we would be resorting to making a small amend in your code itself. So just open your code, and here in the max temp variable we would set the value to a value which is lower than 32. So let's say 30. Now save the file.
So after making the changes in the code, we run it. The sensor reading is greater than the max threshold value, so the buzzer emits a shrilled sound and the blue LED blinks. And we also receive an alert SMS on our registered phone number from the Twilio account.
So now we will go ahead and change the value of the minimum temperature variable so that the reading recorded by our sensor falls below the minimum threshold value. Now you can obviously choose to do this by bringing in some cold object near the sensor, but however, for security reasons, we would choose to do it by making a simple amend in our code. So let us just open the code, and what we will do is we will set this minimum temperature value to a value which is greater than the average reading of the sensor. Now if you remember, then the average reading of the sensor was something around 32 degrees Celsius. So we have to set this value of the variable to a value greater than 32, let's say 40. Now save the file.
So after having made the changes in the code, we run it. The flat sound of the buzzer is already audible and the red LED keeps blinking. An SMS is delivered from our video account to our registered phone number as well. The second reading is also up on screen.